Hi guys, welcome to a new chapter today. Okay, so this is the start of your basic what you could say is the whole lot of arrangement of elements which you can see in a form of a table. Well, the so-called periodic table, a very big achievement for all of the scientists who had put efforts in framing this particular table. Don't you think it's really amazing to have such kind of an arrangement wherein elements have been put in with so much of thought process under one kind of what you could say under one roof itself, wherein all of their properties, okay, not in fact I wouldn't say all of them, but then most of their physical and chemical properties are in a particular order, okay, or else you could talk about the reactivity, okay, the chemical reactions which they have with different groups of elements. Fine. So in those cases, this particular reactivity which is going to be repeating itself at regular intervals, you could say, this was made up by our wonderful scientists who did a brain work of you could say it was for almost a couple of years, not even a couple of years, it was decades which took place to frame this particular table. Well, this table is not an ordinary table though. Okay, and if you believe me, it covers almost 30 to 40% of your chemistry, the whole of chemistry. Okay, so it may be the J level you are talking about or any other competitive level, or say even if you are going beyond your 12th also, this particular periodic table is going to be a very important part of chemistry. So please remember, don't take this so very lightly also. Try to understand the depth of the periodic table, the information which has been given by this table each and every time. Maybe we are talking about atomic sizes, atomic weights, atomic what you could say volumes, find the densities, every other thing is being given by this particular table. So that is the reason I said it was one of the major achievements of the chemists at that point of time. Well, this story is really an amazing one, like the one which we have learned in case of your structure of atom also. Don't you remember the cathode ray tube, the glow, the what you could say according to the polarity of the magnets, or say according to the electrical fields which were applied, there was deflection of the glow which was seen. And it was considered to be quite magical. Of course, the same way, this periodic table is also magical. Why magical? Because it gives me every bit of information, man. May it be your S block, may it be your P block, may it be your D, F. Well, this may sound as a bit a kind of an off-track thing because you are not knowing about SPDF. But then the categorization of this particular table is marvelous. So let us learn about this marvelous part of the chemistry from the very start, okay? Well, I'm not going to get into the very detailed part of it. Of course, we got to stick to JEE, no doubt about it. But then still, we would like to see as to what efforts were poured in by our scientists and what kind of thoughts they had, okay? So if at all you just imagine that you don't know anything about the periodic table, whatever you have learned from your 10th or say from your 9th standard, just forget about it, and try to get absorbed into this wonderful world of the periodic table. Well, let us start the story wherein this periodic table was not known as the periodic table. In fact, the lesson's name is not also periodic table, it's periodic classification of elements. Classification, exactly. Almost in kind of like 1800s or so, you had been knowing about, you could say, around 31 elements at that point of time, okay? And at that point of time, definitely, the chemists who were knowing all of these kind of elements, they were seeking, they were observing some kind of similarities being seen in some of the elements, fine? And then what did they do was, they started thinking as to if at all there is an arrangement which is made so as to accommodate all of these elements in a particular order, fine, so that it's not difficult for the other forthcoming scientists or the forthcoming students who study chemistry or say science to find out as to which property matches with which one. So what can be, what you could say, a kind of combination which would come into the picture, Fine. So that is the reason this kind of arrangement to be made was given a lot of effort. Fine. So back in the 1800s, it was just 31 elements which were known to us. Fine. After that, you could talk about 1865. Okay. In 1865, when what you could say, Sir Lothar, who was a great scientist, okay, and of course, well, a scientist is not known as a scientist once and for all. He starts writing the elements or something like that. It takes years to be recognized as a scientist, guys. Okay, it's not so simple. So he was recognized when it was like maybe like 10 years after whatever he had given to chemistry, to the world of chemistry. Fine. So Sir Lothar and in fact Mr. Dmitry Mendeleev had given in their inputs, a lot of inputs in fact, for this particular arrangement. At that point of time, you could say you were having almost 63 elements in picture. Okay. So with this particular chunk of elements, they were trying to put them into order, into some kind of order. Okay, which could be followed for any kind of discovered elements which would be coming after or in the nearest future. Fine. So they were trying to pave out a way as to what can be the kind of specific order which can be designed in accordance to something which is common in all of them. So definitely we had the invention, or rather ways I would say the discovery of the 3 subatomic particles at that time. The neutrons, the protons, the electrons, yes, we did have. Okay, researchers were on. There were so many people involved in it, and thus they came to know that yes, these are the subatomic particles which are common in each and every element. So let us take the help of these subatomic particles to put them in a proper order. Fine. So in that case, Mr. Lothar, Mr. Dmitry Mendeleev, they had put in efforts and framed the wonderful periodic table. So what was its periodic table and how did it started off? Well, at present, if you could say, you are having almost 118 elements filling up the whole of the periodic table, in which some of them are quite, you could say, a bit of unknown, okay, and some of them are yet to get named in the honor of a scientist, named in the honor of country, okay, which has its origin of this particular element being discovered in its what you could say, in its premises. Fine. So this is the way it all started. So if you go to see altogether, when we take an average of all of the discoveries, it was being done in this way that all of my elements which were having some kind of similar properties, okay, they were grouped. Okay, I've just written props as an abbreviation for properties. These similar properties were grouped together in a kind of a vertical column arrangement. Fine. So that was a bit what you could say an easier task to be done. Fine. And definitely the dissimilar properties were separated out. Okay. So then in that case, as I said, there were more than what you could say 10 to 15 people involved in all these kind of what you could say periodic arrangements, okay, or simply arrangements, I would say. I wouldn't include the word periodic. Fine. So after this, what tend to happen was, as soon as I have said that the year 1800 had found almost 31 elements, there was this one sir, Mr. Johann Toppr. Let me write down the name. Toppr. Okay. So Sir Toppr had given in a particular law which is known as the law of triads. Okay. So triads means a group of 3. And in that case, this particular law said that if at all I'm grouping these elements in such a way that it makes a group of 3. Triads means a group of 3. Okay. So these set of 3 elements are arranged in such a way that if I pick up the atomic weight of the first and the third element, it adds up, it gives me the mean, and this particular mean matches up with the atomic weight of the middle element. Whoa, that was a great one. Okay. So in this case, law of triads had so many kind of arrangements being done. For example, if I cut it short and let you know the idea behind it, if I make 3 columns wherein elements, the atomic weights of them, okay, and then I can have the mean of the first and the third one, okay. Under this, I could have lithium, sodium, and potassium. So the weights go in as follows, that 7, 23, and 39. So if you add up 7 and 39 and take the mean of it, it comes out to be 23, which matches up with the atomic weight of sodium. Fine. Then I could have one more set which is talking about cesium, strontium, and barium. Now, what are the atomic weights of these elements? It's around 40, 88, and 137. So just add it up, guys. Come on. Just get a bit active. So it was almost of around, you could say 88.5 or something. Okay. Then again, I had one more set which was talking about chlorine, bromine, and iodine being clubbed up together. So in this case, the atomic weights were such that it was 35.5, 80, and 127. So then again, the addition of the first and the third element fetched me a figure which was nearby 80. That was something like 81.5, I guess. Okay, 81.25 maybe. Fine. So in such cases, it was actually matching up with the middle element's atomic mass. Okay. So this arrangement was a total go-go. I mean, everyone was agreeing to this. But then, all of the elements weren't making any kind of group of 3 as such. Okay. Means, not every time it was the case that the first and the third element clubbed up together would give me the atomic weight of the second element. No. So in that case, what tended to happen was, this theory went discarded. Okay. So more of thought was being put up. Okay. And in this more of thought process, in 1865, wherein I was having almost 63 elements, Sir Newland came in with his own law. What was it? Let me tell you. It's an interesting law, guys, okay, and it's of course related to music. So in this case, what did he do was, he framed the law of octaves. I guess what you mean by octaves, you know it, right? Octaves is it's a group of 8, octate like a poetry of 8 lines. So simply, octaves is these 8 notes, sa, re, ga, ma, pa, dha, ni, sa. So sa and sa, that is the first and the 8th note, is similar, yes. So Newland sir told us that if at all I arrange the elements in the increasing order of their atomic weights, the first and the 8th element when picked up, it showed me the repeatability of some of its physical and chemical properties. Voila, this was a great discovery, isn't it? What it is saying is, in the increasing order of its atomic weight, okay, increasing order of its atomic weight, the first and the 8th element matched up. Matched up in what sense? In sense of its chemical properties, in sense of its physical properties. So this was a great discovery again. So it was being framed up that yes, first 8th element, okay fine, sodium, aluminium, silicon, phosphorus, sulfur, chlorine, fine. Then we were having lithium, beryllium, boron, carbon, nitrogen and so on. But then this was again being discarded. Why? Because this was true only till calcium. Nothing more than that worked out to be. Okay. And in that case, even the inert gases at that time were left undiscovered. So in that case, this did not form a basis for the classification. Each and every element like that of the 63 number was being classified in this order. No, not all the elements were covered up. So then again it was discarded and we had to find some new ways. Now what were those new ways and what kind of applications were being done were taken up by the scientists who were forthcoming. I mean, they were taking the help of these theories and they were trying to frame out a way as to what it could be. So what it could be, let us see in the next session what was the way which was paved out by the other scientists to give us a proper arrangement as we can see it today. Fine. So let us dive into the next session to see the other stories of the wonderful scientists who gave us this particular amazing chemistry arrangement. See you over there. Thank you.